Okay, today we're going to talk about one-sided limits, and we've already talked about right-hand side and left-hand side, so this should be a little bit of a review. When we're talking about the limit as x approaches c from the right, we kind of still denote that with that little plus value located in the upper right-hand corner. When we talk about a limit approaching from the left-hand side, we're talking about as x approaches c from the left, we use that negative value. And we talk about, again, this is a review, this is from a different video, that a curve has a limit, so there's a limit exists if and only if the right-hand side is equal to the left-hand side. And the point of this is you're eventually going to get into the idea of continuity. So continuity means that there's no breaks, there's no jumps, there's no holes, I have no vertical asymptotes, I don't have anything like that. And so we have a curve that's continuous on a closed interval if it is continuous on the open interval. And we have to assume that my limits are actually approaching the endpoints. That's what it means by the limit as x approaches a from the right is equal to the y value at a, which is that'll be on the right hand or the leftmost endpoint, and the rightmost endpoint would be the limit as x approaches b from the left is equal to the actual y value at b. So let's look at several examples. And so 1 through 10 are all going to correlate with this graph that I have up in the upper right hand corner. And so we're looking at what is the limit as x approaches -3 from the left. And so let's go ahead and check. And so -3 is located right here. And so I want to see what's happening with the function. What's happening as I approach x equals -3? Well, I kind of have this nice linear constant function. So when I come in from the left-hand side, I'm approaching the y value of -5. And so for number 1, I can just go ahead and write is equal to -5. For number 2, I want to check what is the limit as x approaches -3 from the right-hand side. And so let's go back to our graph. And we're just checking what's happening with my function as I approach -3 from the right. So here I come down a little swoop, and you'll notice that I'm approaching the y value of +2. And so I'll just go ahead and write is equal to +2. Number 3, we're checking what is the limit of g of x as x approaches 0 again from the left. So let's go ahead and erase all this stuff right here. So we're checking is what's happening to 0. Where's my function going? What y value is my function going to as I come in from the left? And so as x is equal to 0, I'm coming in from that left-hand side, and the y value that I seem to be approaching is equal to -4. And so I'm just going to go ahead and write is equal to -4. Number 4, they're asking me to find what is g of -3. Well, please don't overthink this. This is essentially an Algebra 1 question. So if I give you the x-coordinate of -3, what is the y-coordinate? So let's go ahead and clean up our graph over here. I can't include this value right here because it's a hole. The point doesn't exist there. So instead, I need to come down and look to see where's the point exists. Well, it looks like the point exists at -3, -5. And so I can go ahead with number 4 and go ahead and write is equal to -5. Number 5 asks us to find the limits of g of x as x approaches -6 from the right. And so let's go ahead and clean up our graph a little bit. And so I'm approaching the x-coordinate of -6. I'm approaching from the right, and it looks like I'm still on that constant function of where y is equal to -5. And so I can go ahead and write for number 5 is equal to -5. Number 6 is a little bit of a tricky kind of question. Notice that there's no plus or minus after that -6 in the upper right-hand corner. So what it's really asking me, does the right-hand limit and the left-hand limit equal each other? That's what it means for a limit to exist. Well, I have a major problem here. If you notice, on the left-hand side, there is no function over here. There's nothing. I have a function on the right-hand side, over here. There's a function. And I have a y value that I am approaching, but I have nothing essentially that's approaching -6 from the left-hand side. And hopefully it should show up somewhere in that red box. Well, there's nothing there. Well, if my left-hand side limit doesn't exist, there's no way for it to be able to equal the right-hand side limit. And so we're actually just going to go ahead and write DNE because there is no left-hand limit for it to exist to. Erase that out. Number 7 asks us to look at 0 from the right-hand side. So let's go back to our graph, and so we're going to come into x equals 0 from the right-hand side, and I hope you notice that we're approaching looks like -4, and so we can go ahead and write -4. Number 8 is asking us, again, similar to number 6, does the left-hand limit equal the right-hand limit? Well, let's look. Let's go ahead and clean this up. And so I have a left-hand limit that's here. I have a right-hand limit that's up here. Well, there's no way that those two are coming out to the same y-coordinate. Well, that's also reflected in the values they gave me. They gave me, on the left-hand side, our limit was equal to -5. On the right-hand side, it was equal to +2, which you can see on the graph, they're not equaling up to the same y value. And so for number 8, since the left-hand limit does not equal the right-hand side limit, we're actually just going to write DNE. Doesn't exist. All right, number 9. So we're looking at what is the limit of g of x as x approaches 0. Well, let's check. If I'm coming in from the left-hand side, it looks like I'm approaching -4. If I'm coming in from the right-hand side, again, it looks like I'm coming to the same spot at -4. And that's also reflected in our two values we have. So here is that limit, here's the algebra part. The limit as x approaches 0 from the left of g of x is equal to -4, and that's also true of the limit of g of x as x approaches 0 from the right is also equal to -4. So since our y values are equal to each other, we can just go ahead and write that y value, which is -4. Alright, we're going to try number 10. And I'm not going to lie to you, this is a little bit of a doozy, so I'll try to weed you through this as easily as I can. And so let's go ahead and do the easy one. From x is equal to -6 to x is equal to -3, I have this nice constant function, which makes it pretty easy. So we can just go ahead and write the equation of that line, which is horizontal. So we're just going to go ahead and write y is equal to, well, if I extend it, I'm going to eventually run into -5. So our equation for that line is y is equal to -5. Alright, now let's go ahead and tackle this ugly parabola. And the roots for this parabola are so ugly that I'm going to have to write it in vertex form. I know you guys are groaning right now. I'm so sorry. But if I try to write this in root form, it's a bit of a disaster. Vertex form's a little bit easier, believe it or not. And so I'll kind of weed you through all this mess. And so I have vertex form is y is equal to some sort of value. We don't really know what that is yet. And this is where we're actually going to write the vertex points. Well, my vertex is located at -2, +4. That's my vertex, -2, 4. And so remember, if I have a negative for my x value, I'm going to go ahead and write a plus. So I'm going to write a +2. And my y value, I'm going to write whatever sign it is. In this case, since 4 is positive, I'm going to write a +4. And my squared goes with the x. And I don't really know what this is. And so I'm just going to go ahead and write a. I'm going to solve for a, and I'll walk you through that. I'm going to pick, in order to solve for it, I'm going to pick a pretty easy value. And so I'm just going to pick 0, -4. So let's go ahead and try to solve for a. So in this case, y is equal to -4. We don't know what a is. And x is equal to 0. So 0 plus 2, hopefully that's not too hard, is going to be 2. So we have 2 squared plus 4. So we're just going to go ahead and solve for a. Well, if I subtract 4 from both sides, I'm going to get -8. And that's going to be equal to a. And if I square 2, I'm going to simplify this, I'm going to get 4. Well, hopefully from here you can see that -8 divided by 4 is equal to -2. And so we're going to write a is equal to -2. So this ugly, ugly, ugly parabola is y is equal to -2 times x plus 2 squared plus 4. Finally, I have a nice linear function. So I'll go ahead and pick a different highlighting color so you can see it. That goes right here. And so I'm just going to go ahead and use y equals mx plus b. Let's make this easy. So my b is the y-intercept. Well, the y-intercept is located at -4. My m is the slope. So it looks like, if I just go ahead and kind of plug this in right here, it looks like, and I start here, it looks like I'm going up 2 and right 3. So up 2, right 3. So my slope is 2/3. So the equation of this line is y equals 2/3x minus 4. So now let's go ahead and start putting all this mess together. All right, you'll notice, so let's go and write our g of x. You'll notice that my constant y value, y equals -5, that's only true between the values between -6 and -3. But we're not going to include -6 because there's a hole there. So when we talk about our boundaries with our piecewise function, we're going to use the less than or the greater hand sign, or sorry, it'll be less than. But we're not going to include it. We're not going to have that little line underneath. So I'll show you what I mean. So g of x is equal to, let's go ahead and write our bracket. And we have -5, that's the equation. And this is true between -6, we're not including it, so we're not going to put that line underneath. And so we have x. And that's going to be less than or equal to -3. And so that's our first part. Now let's tackle our incredibly ugly parabola. Well, a parabola exists between -3. We're not including -3 because there's a hole there on our parabola, and we're going to go all the way down to -4. And we'll go ahead and include that value. And so, from the top, you can see that we had y is equal to -2 times x plus 2 squared, quantity squared, plus 4. So we're going to go ahead and write that. So we have -2 times x plus 2 squared plus 4. That's our ugly parabola. And that parabola is true between the x values of -3. We're not including that -3, so that's why there's no line underneath. And we'll go ahead and include, so that parabola goes between -3 and it goes down to 0, -4, so we're ending at x value of 0. Finally, our last linear portion, which is highlighted in blue. And so we're going to go ahead and say that that value is true between x is equal to 0 and x is equal to +6. So let's go ahead and write our linear function. That'll be 2/3x minus 4. And that's true for x values between 0, and we're not included because it was included in the line above. And we're going to go to, looks like, +6, and we are including that value 6, x value is 6, because there's no hole there.